Wait, no, that's not what I meant. So it'd be 15 over.
I think you're thinking of adding to multiply fractions.
Do you just times them?
Yeah. Just times it.
So, um, 4 over.
You're still thinking of adding. So
Oh. 3
yeah,
over 20.
that's it. Now you see why I put this as in the starter. So this one,
6 over 12.
yes, and I'm not going to simplify it. Okay, so this is adding.
5 over 12.
Yes. Okay. That's fine. That's fine. Okay, this one. And the grades are all wrong, I believe. But anyway. Okay, this one.
Uh, 3 out of 8.
Yep, that's it. Okay, how about this?
Oh, 1 tails and 2 head and then 2 tails. And then 3 head and 3 tails, 4 head and 4 tails, and 5 head and 5 tails.
And then part B.
Um, 1 out of 10.
Yes, so basically there's 10 possibilities and one of them is 1 head, so it's 1 out of 10. Possibilities for this one is 5, for this one is 2. And so when you're saying the possibility of both a 1 and a head, you times. And so that shows you that both and you multiply. Or I suppose BAX, both and multiply. Fine, fine, fine. No. Oops. Fine. Okay, let's do these 3.
Seven over 20. 9 over 20. And 0.
Yes. And so this one here, the probability of not something, so not lime, which you do as lime dash, is 1 minus the probability of lime. So it's always, the probability of not something is always 1 minus the probability of something, because they always have to add up to 1. Okay, how do we do this?
Is it 400 times 0.3?
Yeah, so this is non-calc. Do you know that?
12.
Close. That would be 40 times 0.3.
Oh, 120.
Yes. 20. So this one?
300 times 0.7, so 210.
210, that's fine. 210, so I'd be fine for that. What would this be?
.3.
Yeah. Fine. What would be part B?
Oh, 15.
Green. Yes, 0.3 times 50, 15. And so this here is like the thing we just did a second ago with the 400 times 0.3. They've just put it in a, it just looks a bit different, but it's the same thing. Relative frequency. Okay, these are fine. Yeah. How about this one? Part A?
Um, 0.35.
Well done. 35. Okay. Same thing. Okay, this one. Fill in the blanks.
Um, the Hannah wins is 2/5.
Okay. So let's say this first one. So she wins at badminton is 9 out of 10. She doesn't win at badminton? Probability?
1 out of 10.
Yeah. So same idea for tennis.
3 out of 5.
Yeah. And then the bottom two?
2 out of 5.
Yeah.
And 3 out of 5.
Yeah. What is the probability that she wins both matches?
11/15.
What was the rule for both and? She wins both badminton and tennis.
Oh, times.
Yes.
So 18/50.
Well done. And you don't need to simplify probability fractions because you might need to add them later, and so it's good to keep a common denominator. Okay, similar, this time they are decimals. No, what am I doing? Sorry, this one. This time they're decimals. Put those in the wrong order. Okay, how about this one?
The does not win Hoopla is 0.6.
Mm-hmm.
And then 0.7,
Mm-hmm.
0.3, and 0.7 again.
Probability she wins Hoopla and also wins Coconut Shy.
1.2.
That would be adding them.
0.12.
Yes. So equals 0.12. And in general, you multiply across a tree diagram and you add up and down. Now let me go back. Okay, now this one. There's a trick in this one.
Three out of 8 for the first one.
Mm-hmm.
Then 3 out of 7 for the other one. Then 5 out of 7.
Yep.
And then 2 out of 7.
Well done. Okay. Probability that Dwayne takes marbles of different colors.
That would be 15 over 56 plus
Yep.
15 over 56 again.
Yep.
So 30 over 112.
You add the top and copy the bottom.
Oh, yeah. 56.
Yes. And what that shows you is you have 15 chances out of 56. So it's basically either a red and green or a green and red. And so for either or you add. So either or you add, and then if it's both and you times. Will that be either or? Who knows? Let me just check. Yes. Okay, this time you've got 3 things, so it'll be easier to do it without the tree diagram. How would we do this? And it might be easier, let me just go back, to list the successful outcomes. So for this one, the successful outcomes would be red then green, and then green then red. And so you write it as that first. Okay, how about this
one? It's just loading.
Oh, sorry.
Oh, okay. So it would be red plus blue,
Yeah.
or
Same
plus
color?
green. Oh, same color. Oh, red plus red, and then blue plus blue, and then green plus green.
Yeah.
So,
So probability of getting a red?
five
Mm-hmm.
out of 10.
Yeah. Probability of getting another red?
4 out of 9.
Yeah.
Then 3 out of 10 and 2 out of 9. And then 2 out of 10 and 1 out of 9.
So what do you do with those?
Times them.
Yeah.
20 over 90.
Mm-hmm.
6 over 90. And 2 over 90.
Yeah. And then?
Then add them together.
Yes.
So 20 plus 6 plus 2, 28 over 90.
Well done. 20 over 90. Got it. Any questions there?
Nope.
Okay. So that was same color. This one not the same. How would you go about that?
So it could be P and C, or P and G, or C and G.
So there's actually a trick to this one. You know the way before we had the one earlier, it was like red and green marbles or something? And
Yeah.
you did like 15 over 56 plus 15 over 56. And that's because it could be either red and green or green and red. So this one could be either plain and chocolate, or it could be chocolate and plain. So that would give us a total of 6. So we could do it. We could do it that way, or we could just get our answer in double. Sorry, go on.
Chocolate and ginger as well.
Chocolate. So you have that one down here. So all of them will be replicated. So one way you can do it is you can do what we just did and then double your answer. Or the probability that they're not the same, what would that be equal to? Probability that they're not the same in relation to the probability that they are the same.
Six.
Probability that they are not the same is 1 minus the probability that they are the same.
Oh.
So we can either find the probability that they're different, like one each, and then double our answer. Like with the 15 over 56, you double it 30 over 56. Or we can find the probability that they are the same and do 1 minus that. Do you have any preference?
No, I don't.
Let's do probability that they are the same, because we just did that one and found you a good
Okay.
one. So probability that they are the same.
12 over 20, and then 11 over 19, then 5 over 20 and 4 over 19, and 3 over 20 and 2 over 19.
So
And
yes, sorry, go on.
then times them.
Yes. So the denominator is 380. That's so 132, 26. 1. What would that give you?
The screen is frozen.
So I think it's 156 over 380. So does it just load in a second? Is that what happens? Or do I need to?
I don't know. It's
Okay. Well, of course, I was just literally doing exactly the same thing over and over again. Okay, so this one, it was 156 over 380. Is that the final answer?
no.
What do we have to do?
Minus 1. It times it.
Yeah, so 1 minus 156 over 80, and 1 is the same as 380 over 80. Minus 156 over 380. So 380, take away 156. 224. Are we slightly off? Let's see. This says 222. 158. 130. Oh, 158. Sorry. 258. And so that would be 222. Yeah. Okay, so for this one, that they're not the same type, it doubles the odds. And so we could have done the probability of the one that you did. So plain and chocolate, plain and ginger, ginger and chocolate. We would have gotten, I believe, 111 over 380, and you would then double that because there's double the possibilities, double the chances. Or you can do the probability that they are the same, and then do 1 take away the probability that they are the same. So they have to add up to 1. Any questions there?
Nope.
Okay. How would we do part B for this?
Oh, 5 out of 6.
Enough. Well, what's the?
Oh wait, no.
What are the successful outcomes?
The 2s and the 3s would be if he got 1 first.
Okay, so 1 and then what are all the possibilities?
Oh, 1.
The second number has to be greater than the first. That would be equal to
2.
yeah. So 1 and then a 2.
And then 1 and 3.
And is that it?
And 2 and 3.
Well done. And will this be the type like the 1 minus or doubling type, or will this just be you get the answer and leave it?
The answer, like you get the answer.
Yes, this would give you the answer in one go, and I think you'd be fine for that. So it's just the same. Well, let's just do this bit. So what will be the first two?
2 over 7 and 3 over 5.
Not 5?
No, 6.
Yes. Okay. I think you'd be fine for the rest of that. Okay, so what type is this? Will we double it at the end or do 1 minus, or just it gives us the answer straight away?
1 minus.
Yes. I'll write it as the probability of not the same equals 1 minus probability of the same. Okay, I think you'd be fine for that. That's all of those. So 3 diagrams and everything so far, x1/2 or tick.
Tick.
Okay, Venn diagrams. Put these numbers onto the diagram. Multiples of 3 in there, non-multiples of 3 outside.
2 is inside.
Is 2 a multiple of 3? Multiple of 3 means 3 times table.
Oh, no, wait. No,
So where does the 2 go?
outside.
Yeah. Next.
3 inside.
Yeah.
5 outside.
Yeah.
6 inside.
Yeah, and so on. Okay, what would go where?
Uh, 10 in the first circle.
The left?
Yeah.
Okay.
58 in the right.
Yeah.
78 in the right. 80 in the middle. 30 on the left. 60 in the middle. 51 on the right. And 28 outside.
And if you were to summarize that data down, how would you say, like, what number are in each region?
2 and 2 and 3 and 1 out the outside.
What's the probability of getting no, I won't skip ahead. Okay, so this is one they did for this. What is the probability of so a member is chosen at random? What's the probability that they do yoga?
18 out of 53.
And the 7 in the middle, do they do yoga?
Yes. Oh, yeah.
So what would that affect?
25.
Yes.
50.
Okay, rest of those are fine. That's fine. Okay, this time you have a blank Venn diagram and you have to fill it in.
So there's 20 in the middle.
Yeah.
Then there's 50 in the track.
Well,
Then 70 on the outside. Then 60 in the field.
well. Sorry. Okay, how about this one?
Um, 6 in abseiling.
6 in abseiling. So there.
Yeah.
Okay.
21 in between abseiling and cycling.
Abseiling and cycling. So the way you did this one was you started from the middle and worked your way out. And so that's the way I'd recommend you always do it. Start from this very center, work your way out, and the only exception is the outside, which isn't affected by them. So for this one, I'd start from the very middle and then do the middles. So those three.
Oh, 14.
Yeah. And so now let's do this 21 did abseiling and cycling.
It'd have to be 21 minus 14.
Yes.
And then wouldn't you have to minus those who did sailing as well?
No, this is just abseiling and cycling. Because the 14 middle did abseiling and cycling. They also did other stuff, but that doesn't affect this.
Okay. So 7.
Yeah. So that's a total of abseiling cycling 21. Because those 14 did one.
Then 1 in between sailing and abseiling.
Abseiling and sailing. Why is there just 1?
Because 14 plus 6 and 7 is 37, and it says 38 did abseiling.
Oh, okay. So 38 did abseiling altogether.
Oh wait, would it be 11?
Yes.
And then in between sailing and cycling is 10.
It's 10, yeah.
And then cycling is 5.
Mm-hmm.
And then 90 minus 58.
We've got two unknowns.
Wait. Minus 52.
Yeah, and what is on the outside?
6.
Yes. So 90 minus 52 is 28, is it?
Yeah.
That was 31. Let's see. 10, 11, 14, 5, 7, 6, 6. Okay, so everything's correct. It's just that last bit. So yeah, it's basically 90 minus the total of those gives you the answer. And turns out it was 31. Okay. This one is... Sorry, any questions about that previous one?
No.
Okay, so this one is both and. It's the intersection. It's where they overlap. And they write that as A and B, fish and chips. Both and. So this one, this is either or. So either A or B, which includes both. Union, wedding rings, either A or B, union. This one, complement, this means not. So A dash means not A. If someone says you're dashing, they're giving you a compliment. I am not dashing. Not A. A dash compliment. Okay. This one, set A, what are the regions?
The complement. No, wait.
Just in terms of left, middle, right, and outside.
Left and middle.
Yeah. Set B.
Right and middle.
Yeah. Both A and B.
Left, middle, and right.
That is either A or B. Both A and B.
Left.
No. So the regions for if someone.
Oh, middle.
Yeah. Neither A nor B.
Outside.
Yeah. Not A.
Right and outside.
Not B.
Left and outside.
And I suppose I should say neither A nor B. What would that be?
Outside.
Yes. Okay, so this one, list the set part A.
Two.
Yeah.
4.
Mm-hmm.
And 6.
And skip to part D.
1, 2, 3, 4, 5, 6, 8, 10, 12.
Yes, well done. So you just don't do the same ones twice. Okay, what is this?
0.1.
Yes. Where do I shade?
The middle, the intersection.
Yeah. Where do I shade?
The everything except the outside.
Yeah, left, middle, and right. Okay, so this one, where do I shade? And it might be easier to list the regions first. So not A, not B.
The outside.
Yeah, it's the outside, fine. This one.
The outside and the right.
Anything else?
No.
Regions for B.
Oh, the middle.
Yes. So the only one was not the left. This one.
All of it except the B. The right.
This is the intersection. This is N.
Oh.
And you can always say what the regions are.
That's A, like this whole circle.
So what regions?
L and M.
Yeah. And then this one.
O and L.
Yeah. So what am I shading?
L.
Yes. Just L.
Okay.
Because it's the intersection. So it's what they have in common. And so the overlap is L. If it was the U, then it would be left and middle and outside. Okay. Any idea about this one? So these are people who eat apples. These are people who eat bananas.
So it would be A dash and B.
Yeah. Or you can just do it with numbers if you prefer.
Oh, just 41 out of 100.
So because this is a given type, it is given that they do not eat bananas. And so it is out of people who don't eat bananas.
Oh, 58.
Yeah. And so this one.
Um, 11.
Right.
Out of 25.
Given that a person has a brother.
Oh, out of 14. Wait. Oh, out of 30.
Yes. This one.
$15 out of 25.
Let's see this one. They have not visited Spain, so not Spain is 25. Given that a person selected has visited France, so it's given that the person selected has visited France. So it's given they have visited France. So how many people visited France?
20.
And of those, how many have not visited Spain?
Oh, 10.
Yeah. Okay, how about this? So this is people who drink tea, coffee, and milk.
Oh, would it be 23?
How do you get 23?
Like, 16 plus 5 plus 2.
It's given they like tea. So it's given that they like tea.
Oh, 21
Yeah.
out of 34.
44. I'm sure you'll be okay with it. Oh, that's the wrong answer. It's 4 marks for that. No, wrong answer. Okay, and this one. Rugby, football, cricket.
Um, 11, no. It's 19 out of 36.
I think it's 26, is it? Oh, 27. Whatever. So we're just adding those. 8, 16, yeah, 27. Were you just adding these up, was it?
Yeah.
Okay. Yes, so that's all of probability anyway. How was that for you, Hannah?
Good.
So it's done. A lot of it is easy, and then some of it just takes some thinking. Anything in particular you want to do next time, or should I pick?
You can choose.
Okay, so in that case, so we did those 2 chapters, probability, Venn. So the next would be ratio and proportion. Okay, I'd have to do the hard ones from ratio and proportion. Yeah, the probability ones. Yeah. Any questions for me in general?
No.
Okay, well then, Hannah, you did great. I look forward to talking again next week.
Thank you. Bye.
Have a good week. Goodbye.